Hello everyone. Last time I showed you how to solve an equation using fourth, and we had a look at examples of quadratic equations, and I wanted to show you a little extension I've added to the program. So last time, if we consider an example, we can take something like this. We were able to type something like 1 to A minus 5 to B and 6 to C, and then we're able to get x1, put it on the stack, and x2. So that's all nice, but it'd be good to have a representation of the quadratic equation, wouldn't it? And it'd be nice perhaps to go from the expanded form to the factorized form. So let me show you the word I've added. It's factor, and there you go. So that's now factorized the quadratic equation, and I've added another word too. This one's a little bit more manual, but it's called expand. You have to give it these two arguments here, and you get the original expanded equation. So notice here that matches what I did above: 1 to A minus 5 to B and 6 to C. So let's have a little look at the code that I did to do this. I've added some new variables called vx1 and vx2, and the v is just standing for variable, and it's to make these words different from x1 and x2 as seen before, because they're not the same thing. The previous ones were calculating the values, but these are actually going to hold values when we are trying to do our calculations. To make it easy to print out the factorized version, I've defined this new printing word called dot plus, and what it basically does is it checks if the number is negative, and if it's negative it prints the minus sign, and if it's positive it prints the plus sign. Then it prints the number itself, but it actually prints the absolute value. So that means that if the number was negative, it prints it as if it was a positive number. So this prevents us from getting two minus symbols. So there might be another way to do this in fourth, but this was fairly easy to write and seemed quite logical. Then we come to the word factor. Now dot plus here is the print string operator for fourth. So let me show you an example. This is how hello world would look in fourth. So hello dot quote hello world. So we've now defined hello. I think I defined hello before actually, and as you can see it prints out hello world. So if we go back to factor, what we're printing here is open bracket x, and then we calculate the value of x1 and we negate it. So why are we negating it? Well, if you look at our example here, x minus 2 and x minus 3, the value of x in these cases is either 2 or 3, because remember, this equation is equal to 0. So 2 minus 2 is 0 and 3 minus 3 is 0. But notice this number that's next to x here is the inverse, it's the negative. So if x is 2, this number here needs to be minus 2. So that's why we add this negate. I also could have defined an operator called dot minus. In fact, I can probably do that now, because all we need to do is negate before doing dot plus. So let's define that actually. And that's as simple as negate dot plus. Lovely. So look how easy and interactive it is when we use fourth. And let me make sure I remove this negate, because sometimes you want to make things nice and short. That's the advantage of mathematical notation. And so yeah, we're basically just printing the the value of x1 with either a minus sign or a plus sign, and then we print the rest of the brackets and the next x. We do the same thing with x2, the second value of x, and then the final closing bracket. So that's how I was able to define factor, and it's quite nice, isn't it, just to be able to type factor and then you can visually see what you're working with. And then I thought, well, why not create something that matches it, called expand. Now expand might look a bit confusing, but it's kind of because it's doing two things. One thing that expand is doing is it's calculating the A, B and C values. Well, it only calculates B and C, it doesn't calculate A, because you technically don't have to have A. But it calculates them and it puts them into those values, and then the actual printing starts a bit later on, where we print A and then we print the x squared part, and then we use a dot plus on B and C. So that way we're also able to expand. We're able to expand our equation. So I hope that was interesting to you. And what I would like to be able to illustrate in the future is being able to treat programs in the same way. Notice how we're able to simplify things. We're able to go between different forms using this mathematical notation. Well, imagine being able to do that with a programming language. That would be quite exciting, wouldn't it? So let me know if that would interest you, and I hope this helped.